Welcome to today's deep dive. So before we even jump into the sources, I want you to just picture something for a second. Picture an emperor penguin.
Okay, classic nature imagery.
Right. It's standing completely alone on this tiny, rapidly shrinking block of ice. And the sky behind it is this turbulent, almost ominous sunset.
Oh, wow.
Yeah. And floating right there in the dark, freezing water, literally just feet away from the penguin, is a discarded plastic water bottle.
That is a bleak image.
It is. And we're sitting here today looking at this exact visual detailed in our main source document, which is titled The Sixth Mass Extinction.
Right.
And it perfectly encapsulates this reality that honestly just hit the scientific community with the force of a tidal wave recently. Because the IUCN, the International Union for Conservation of Nature, has officially classified both the emperor penguin and the Antarctic fur seal as endangered.
Which is wild because we've historically viewed those specific animals as, the ultimate survivors.
Exactly. They thrive in the most extreme, unforgiving environments on Earth. And now their populations are just buckling.
Yeah, and what's fascinating here is that the text makes a really compelling argument. We literally cannot afford to view these animals as isolated tragedies.
Like it's just about the penguins.
Right. It's not. The decline of these iconic species, it's a glaring indicator of systemic planetary stress. Think of them as the stress sensors on a giant suspension bridge.
Ooh, I like that analogy.
Yeah, when those cables start to snap, the structural integrity of the entire ecosystem is compromised. The core thesis of the deep dive today is that we are actively transitioning between two profound states right now: ecological collapse and conscious choice.
And that transition implies a timeline, right? To understand where we are on that timeline, we have to look at the geological scorecard, because the document repeatedly uses the phrase mass extinction.
Yes, it does.
Okay, let's unpack this, because we hear that term thrown around casually a lot, mostly in sci-fi movies or apocalyptic fiction. But in conservation biology, it's not a metaphor.
No, not at all.
It has a strict numerical definition.
It absolutely does. A mass extinction is defined strictly as a period where at least 75% of all species disappear within a geologically short time frame.
Wait, 75%?
Yeah.
That's 3/4 of all life on Earth just wiped off the board.
Completely erased. And the document details that this has happened 5 times in our planet's deep past. Scientists call them the Big Five.
Right.
So we're talking about the Ordovician-Silurian, the Late Devonian, the Permian-Triassic.
Ones you learn about in high school earth science, yeah.
Exactly, the Triassic-Jurassic and the Cretaceous-Paleogene events. But the unifying characteristic of those past 5 extinctions is the mechanics behind them. They were driven entirely by massive, uncontrollable natural forces.
Like a giant asteroid.
Right, asteroid impacts altering the atmosphere, or periods of just intense, prolonged volcanic cataclysms that fundamentally change the air and the oceans.
So I want to look at the speed of this, because the source brings up the background extinction rate, which is crucial here. Like, species phase out naturally all the time, right?
Oh, sure. Evolution is constantly turning over.
Yeah, I've always thought of the background extinction rate as a slow natural leak in a tire. Over millions of years, certain genetic lineages just kind of reach the end of their run.
That's a great way to think about it.
But this text notes that our current extinction rate is tens to hundreds of times faster than that baseline historical average, which is crazy.
Yeah.
Because we aren't a 6-mile wide asteroid.
No, we're not.
And we aren't a supervolcano cracking open the Earth's crust. So, how are we causing damage that fast?
Well, the explanation lies in a completely new geological epoch. The text identifies this as the Anthropocene.
The age of humans.
Exactly. For the first time in the 4.5 billion year history of the planet, a mass extinction event is not the result of tectonic plates or, space rocks.
Yeah.
The single dominant force driving the rapid loss of biodiversity is human activity.
Us.
Just us. The sheer scale and velocity of our global footprint have taken that slow, natural tire leak you mentioned and basically accelerated it into a catastrophic blowout.
So the text outlines the specific weapons we're using to do this, framing them as a convergence of human-induced pressures. And tracing the causal links between them is just fascinating.
It really is.
If we start with the first driver, climate change, and bring it back to that emperor penguin, it's not just that the air is getting slightly warmer for them.
Right, structural.
Exactly. The rising global temperatures are fundamentally altering the physics of their environment. It destroys the stable sea ice, which is their mandatory breeding ground.
They need that ice.
Yeah. Without a stable platform that lasts long enough for the chicks to fledge, their reproductive success basically drops to 0.
And that is a direct erasure of required habitat.
Right.
which naturally triggers a domino effect into the next major pressure,
Right.
which is habitat destruction on land.
Driver number 2.
Yep. As climate patterns shift, animals are forced to migrate just to survive. But the landscapes they're trying to move through have been fundamentally altered by us.
Oh, so?
Well, the document uses a very specific chilling phrase here. It describes how vast, continuous ecosystems, like tropical rainforests, the lungs of the earth, are being systematically fragmented into ecological islands.
Oh, wow. So you chop a continuous forest up with like highways, industrial agriculture, urban sprawl, and suddenly you don't have an ecosystem anymore. You have this scattered archipelago of isolated tree patches.
Precisely. And the biological consequences of that geometry are just devastating. Because when you trap a species on an ecological island, they face a massive genetic bottleneck.
Because they can't cross the highway to find a mate.
Exactly. They cannot forage widely, and crucially, they cannot interbreed with neighboring populations. Over just a few generations, that lack of genetic mixing severely weakens their immune systems.
Making them sitting ducks for disease.
Sitting ducks. They become incredibly vulnerable to new viruses or even just slight environmental shifts. Plus, you introduce the edge effect.
What's that?
So the perimeter of a fragmented forest is hotter, drier, and more exposed to wind than the deep, dark interior canopy. You alter the microclimate so drastically that even the plant life within that fragment begins to die off.
So the animals are basically confined to these shrinking, degrading islands, which forces them into closer contact with the third major pressure the text outlines. Pervasive pollution.
Yeah, this one is heavy.
Think back to that plastic bottle bobbing next to the penguin in the intro. The text details how synthetic pollutants have infiltrated literally every single corner of the biosphere.
Everywhere.
Yeah. Microplastics have been documented in the deepest, darkest trenches of the ocean floor and embedded in the most remote, pristine Arctic ice. But the document goes way beyond just the physical presence of trash.
It goes to the microscopic level.
Right, it delves into the cellular level, specifically highlighting chemical pollutants that act as endocrine disruptors.
And the mechanics of endocrine disruption are particularly insidious. We're talking about synthetic chemicals often found in agricultural runoff, industrial waste, everyday plastics that essentially hack a wildlife population's internal biological systems.
Hack them how?
On a cellular level, these chemicals mimic or block natural hormones.
So they scramble the biological signals?
Totally.
Like a receptor cell is looking for estrogen or testosterone, and instead it binds with a synthetic plasticizer from a water bottle.
Which completely derails their development and baseline survival. I mean, the text points to entire populations of amphibians and fish that are literally physically unable to reproduce now.
That is terrifying.
Or they're experiencing severe developmental mutations simply because the chemical makeup of their watershed has been fundamentally altered. They survive the habitat fragmentation only to be sterilized by the water they swim in.
Man, and if we look out from those rivers to the oceans, we see the fourth major pressure compounding all of this. The oceans are under siege.
Absolutely.
They're taking a massive hit from overfishing, but also from acidification. The text brings up mass coral bleaching, and the chemistry behind that is just brutal.
It really is.
Because the oceans absorb a massive amount of our excess carbon dioxide, and when CO2 mixes with seawater, it creates carbonic acid, which naturally lowers the overall pH of the ocean.
It creates an environment where marine calcifiers just cannot survive. That increased acidity literally consumes carbonate ions in the water.
And they need those ions, right?
Yes. Those ions are the exact building blocks that corals, oysters, and certain microscopic plankton rely on to construct their calcium carbonate shells and skeletons.
It's essentially osteoporosis of the sea.
That is a brilliant way to put it, yes.
Yeah. The corals literally cannot build their own structural architecture. And then you add to that the constant movement of global trade acting as this superhighway for invasive species.
Riding the wave of global shipping.
Right, crossing oceans and outcompeting native life. You have a perfect storm. It is an assault from every conceivable biological, chemical, and physical angle.
And that convergence is what makes the Anthropocene so lethal. But, it's vital to recognize that this web of pressures doesn't just impact wildlife in remote locations.
Right. If you live in a city or the suburbs, it is so easy to look at a list of dying coral reefs and struggling penguins and think, well, that is tragic, but it's a nature documentary problem.
Doesn't affect my morning commute?
Exactly. It doesn't affect my daily life. But to understand how this fragmentation impacts you directly, we have to look at biodiversity not as a zoo with separate enclosures, but as a massive planetary game of ecological Jenga.
I love the Jenga analogy. The text formalizes that exact concept as the trophic cascade. In an ecosystem, every single species plays a functional role.
They have a job.
Right. You have bees pollinating crops, apex predators like wolves keeping herbivore populations in check so they don't completely overgraze forests, and microscopic fungi cycling vital nutrients deep in the soil.
So in a Jenga tower, every block is bearing the weight of the structure.
Yes.
If you pull out just one block, if you lose a single keystone species, you don't just lose that one animal, you trigger a whole chain reaction.
A total cascade. The loss of an apex predator allows prey to overpopulate, which decimates plant life, which leads to massive soil erosion, which ultimately alters the flow of rivers.
That's insane.
That is a trophic cascade. And if we connect this to the bigger picture, the text provides a statistic that really illustrates the sheer scale of the blocks we are currently pulling from the tower. Over 1 million species are presently at risk of extinction.
1 million blocks are loose.
1 million.
And the document specifically points beyond just the large photogenic mammals to the foundational blocks. We're talking declining insect populations, collapsing global fisheries, disappearing amphibians.
And the direct impact on you, the listener, is immediate and severe. Because the text explicitly outlines that ecosystems provide baseline services that underwrite the entire human economy.
Right. Nature isn't just pretty to look at.
No, it does the heavy lifting, the purification of our drinking water, the microbial health of the fertile soil required to grow global food supplies, the regulation of local climates and weather patterns.
So when that ecosystem collapses, it's not an abstract tragedy. It is the price of your groceries doubling because the soil microbiome is dead and crops are failing.
Exactly.
It is the quality and safety of the tap water flowing into your kitchen. We rely on the Jenga tower to live. When it falls, we fall with it.
And the severity of that reality brings the document to a really profound philosophical and ethical dimension.
It gets deep.
It does. This crisis forces a total reevaluation of what philosophers term the anthropocentric worldview.
Which is what, exactly?
That's the deeply ingrained perspective that humans sit at the center of the universe, and all other life exists merely as a resource for our extraction and utility.
Ah, got it.
The text challenges this directly, asking, do other living systems have intrinsic value? Do they have a right to exist regardless of their immediate economic utility to us?
It is a massive shift in baseline thinking, moving from, what timber yield can we extract from this forest this quarter, to what is the intrinsic biological value of this forest remaining intact.
To build on that, the text introduces the concept of intergenerational justice.
This part was fascinating.
Right. The geological and biological choices we are making today, the carbon we emit, the aquifers we drain, the genetic diversity we extinguish, will permanently dictate the parameters of the world inherited by future generations.
The people coming after us.
Exactly. The moral imperative detailed in the source material isn't just about preserving ecology for ecology's sake. It is about the fundamental justice owed to people who haven't even been born yet. They are the ones who will be forced to navigate the degraded biosphere we leave behind.
Yeah, and here's where it gets really interesting. Because faced with a burden, that heavy human nature tends to look for a quick exit strategy.
We love a quick fix.
We do, usually in the form of a technological silver bullet. And as someone who follows the tech sector pretty closely, I see the headlines every single day.
Oh, they're everywhere.
We are building massive carbon capture machines to scrub CO2 directly from the atmosphere. We are modeling solar geoengineering to reflect sunlight and cool the planet.
Right.
There are even well-funded genetic rescue and de-extinction programs on the horizon, actively trying to use CRISPR to bring back proxies of the woolly mammoth to rewild the tundra.
It sounds like science fiction.
It really does. And it is very tempting to look at all of that and assume, hey, doesn't that mean we can just invent our way out of this crisis and keep living the exact way we do?
Yeah, but the document provides a rigorous, very sobering reality check to that exact kind of technological optimism.
It throws some cold water on it.
It really does. While those innovations represent incredible scientific achievements, and they absolutely warrant continued research, relying on them as a primary solution is a highly dangerous distraction.
Because they treat the symptom, not the underlying disease.
Exactly. You cannot engineer your way out of a fundamentally unsustainable system. The text stresses that technological band-aids cannot replace the urgent requirement for deep systemic change.
Because you're still creating the problem.
Right. If you deploy fleets of carbon scrubbing machines, but you simultaneously continue to clear-cut the Amazon rainforest for cattle ranching, and you pour thousands of tons of synthetic microplastics into the ocean. The mass extinction event continues completely unabated.
The tech doesn't stop the habitat loss.
No. The root cause is the mechanics of our consumption, our global economic structures, and our resource governance.
You're essentially still ripping blocks out of the Jenga tower. You're just doing it with highly advanced machinery now.
That is exactly it.
So the source material points to sustainable development as the actual framework required, which, sounds like a corporate buzzword.
It does get thrown around a lot in boardrooms.
Yeah, but the text defines it with strict parameters. It is the rigorous balancing of economic growth, environmental protection, and social equity.
You cannot prioritize one at the total expense of the others.
Right. But the document notes that policy and legislation alone are basically insufficient. I mean, you can draft all the international treaties in the world, but it demands a profound cultural shift.
A cultural shift where global societies actually culturally and economically value long-term planetary health over short-term quarterly financial gains.
Which is easier said than done.
Very much so. And this raises an important question, right? Where do we stand right now? The models cited in the text indicate that the window to make this shift is incredibly narrow. They point to the next decade starting right now in 2026 as the critical tipping point.
And what threatens to slam that window shut faster than anything else is the mechanics of feedback loops.
Oh, the feedback loops are terrifying.
The text specifically highlights melting permafrost, which is just a perfect example of how an ecosystem can suddenly turn against itself.
So the Arctic permafrost is essentially a massive geological freezer spanning the northern latitudes.
Okay.
And it holds billions of tons of ancient frozen organic matter, plant life and animal remains that have been locked in ice for millennia. But as human-driven warming increases global temperatures, that freezer unplugs.
And the ice thaws.
It thaws. And it doesn't just release water.
It releases all that organic material, and the microbial world wakes up.
Yes. The microbes begin to digest and break down that ancient carbon. And as a byproduct of that digestion, they release enormous quantities of methane.
Which is bad.
Very bad. Methane is a greenhouse gas that is incredibly potent. It traps significantly more heat in the atmosphere than carbon dioxide over a 20-year time frame.
Wow.
So that newly released methane hits the atmosphere, the planet warms even faster, which thaws deeper layers of permafrost.
Which wakes up more microbes to release more methane. It is a self-amplifying cycle, a cascading system failure. And if we push the global temperature past a certain threshold, those feedback loops just take over entirely, accelerating the crisis completely beyond human intervention, regardless of what policies we try to implement after the fact.
The urgency is undeniable, but, and this is a big but, the text explicitly cautions against fatalism.
Yes. I want to make sure you, listening to this, don't walk away feeling completely hopeless, because the window of opportunity is narrowing, but it is still open.
It is.
The document highlights verifiable, real conservation successes. We've seen the recovery of specific whale populations that were hunted to the absolute brink, rebounding once international treaties were strictly enforced.
And the text points to the successful reintroduction of keystone species, bringing apex predators or specific herbivores back to an area, which fundamentally repairs and rebalances entire local ecosystems.
So the mechanics of the trophic cascade can actually work in reverse to heal a landscape.
Exactly.
Yeah.
The real challenge, detailed in the document, isn't a lack of knowledge on how to save species. The challenge is scaling those proven efforts up to a global systemic level.
We know what to do, we just have to do it everywhere.
Right. It requires elevating grassroots movements, utilizing indigenous knowledge systems that have successfully managed complex landscapes for thousands of years, and making urban areas greener.
Like rewilding projects in major cities.
Yes.
Designing sustainable transit and green architecture to reduce our footprint. The blueprint exists. I mean, the text mentions international frameworks like the Paris Accord, but points out that implementation is just really uneven.
Constantly bottlenecked by short-term political interests.
Right. So what does this all mean? Synthesizing all the data and the warnings from the Sixth Mass Extinction 2026, the core takeaway is pretty profound. The Sixth Mass Extinction isn't some future threat for our grandkids to deal with. It is our present reality. It is symbolized right now by that lone penguin on the ice. We caused it, but we also have the blueprint to stop it.
And the document concludes by framing the ultimate question, not around whether we are capable of altering the planet, because we already have.
We've proved we can do that.
Yeah, we've changed the pH of the global oceans. The question is whether we can do so responsibly, with the foresight and humility required to preserve the web of life that sustains us.
And as we wrap up this deep dive, I want to leave you with a final thought to mull over. Something that builds on this source material but projects it deep into the future.
Okay.
Think about those first 5 mass extinctions we talked about earlier. We only know about them because of the fossilized rock layers they left behind in the Earth's crust.
Right. The geological record.
Exactly. So 100 million years from now, when future geologists are digging through the rock layer of the year 2026, the Anthropocene, what exactly will they find?
Oh, that's a great question.
Will they find the fossilized remains of a plastic bottle in a completely collapsed Jenga tower? Or will they find the exact moment in the Earth's strata where one species finally decided to become the conscious stewards of the planet, the layer they dig up? Well, it's the one you are writing today. Thank you so much for joining us. We'll see you next time.